This next section is section 11.3, rates of change. Whenever we talk about the phrase rates of change in calculus, we're really talking about slope. You remember slope. Slope is when you talk about rise over run, or the change in y divided by the change in the x. This is the same concept. In an application or word problem, we usually use the phrase rate of change when we're describing this. So a rate of change could be something like find the rate of change of this function. They're really saying find the slope. Now you may recall a formula for slope that looks like this. And this has to do with when you have 2 points. One point is x1, y1. One point is x2, y2. The slope is y2 minus y1 divided by x2 minus x1. That's fine. There's nothing wrong with this. This is when you have 2 points. Now we're going to describe this a little differently, but it's going to be the same concept. So instead of using this notation, what I want to do is call y f of x, and now you have this, f of x2 minus f of x1 all over x2 minus x1. That's another way to write slope. It's the same thing. I just wrote it using function notation. There's one more way we're going to write this. Now we're going to let x2 minus x1 be a variable called h. So this is the distance, the difference between x2 and x1. And now our slope is going to be this. M is equal to f of x1 plus h minus f of x1 all over h. And we're going to be using this as what we call our average rate of change. So we're going to use average rate of change as this formula here. So here's an example. Find the average rate of change between x equals 1 and x equals 4 for the function f of x equals x squared plus 1. So what we do is we write down our formula. M is equal to f of x1 plus h minus f of x1 all over h. Now we've got to find out what all this stuff is. Well, luckily they told us what x1 is. x1 is our first x value. That's given. Now h is x2 minus x1. For this problem, that's 4 minus 1, or 3. Now we can plug in to this formula everything that we were just told. So, simplify. And now plug into your function. Your function is x squared plus 1. So you need to plug these into this function. That's f of x1 plus h minus f of x1. Oops. Don't do that. Do this instead. Ha. 16 plus 1 minus 2, 3. And when you add this together, you get 15 over 3, which is 5. So what that says is the slope, whatever this function looks like, the slope between those 2 points is a slope of 5. Now, that's fine. There's nothing wrong with average rate of change. But we're also interested in the instantaneous rate of change. The instantaneous rate of change adds one other thing to this formula. They say the limit as h goes to 0. So what are they talking about? Well, here's what they're talking about. let's say that this is x1. This is our fixed point. We're not going to move this. Now here, we're going to have h be the distance between this and x of 2. So this average rate of change is what we call a secant line. It doesn't really match the slope at any one point, just some point in the middle here. It just looks this way. If we make limit as h goes to 0, as h goes down to 0, this point is going to start moving this way. And you're going to start to see a pattern. If I zoom in a little bit on this, this is hard to see. If I zoom in on this a little bit, what you'd see is that the slope is getting closer and closer and closer to a tangent line. It's getting closer and closer and closer to just one point. Do you agree that the limit as h goes to 0 will just have the slope at that one point? So if that's the case, this is what this is about. This is the instantaneous rate of change. So let's actually find one of those, and I think you'll see it's not that difficult to do. Okay? So here's an example. Find the instantaneous rate of change try to find a good example of f of x equals x squared plus x as x1 equals 5. They don't give you two numbers now. Now they just give you one. That's all that we need. So here's what we're going to do. The limit as h goes to 0 of f of 5 plus h minus f of 5 all over h. We don't know what h is now. H is going to go to 0. We can't just plug in 0 for h. We'd be dividing by 0. Let's see what happens with the algebra. This is just f of 5 plus h minus, big parentheses, f of 5 I know it looks like a lot, but good things are going to happen to this. Things are going to settle down quite a bit. So let's see. Limit as h goes to 0 of, this is, don't forget to FOIL this out, 25 plus 10h plus h squared plus 5 plus h minus, this is just 25 plus 5 all over h. Please notice the subtraction. That means everything over here is going to be subtracted and good things happen. It's 25 minus 25 and 5 minus 5. That all goes away. And you're left with this. 10h plus h squared plus another h all over h. Let's collect like terms. And now you can't just cancel here. A lot of people like to just slash things out, but no, you have to factor before you can cancel. Take an h out of the top. Do you see how they have an h in common? And now you can cancel out an h. Can we plug in 0 for h now? Yes, because we're not dividing by 0. You are going to want to try to look for shortcuts on this problem. Let me save you the trouble. Don't look for shortcuts on this problem. There are no shortcuts for this problem. This is what this problem is supposed to look like. So please don't look for shortcuts for this.